Hey 7th graders, welcome back to your YouTube homework review with Mr. Sarley. So yesterday on the homework you guys were adding fractions with like and unlike denominators because we're reviewing all of these things that we need to be able to do in 7th grade. Today we're going to continue the same thing, but our answers are sometimes going to be bigger than a whole. So we have to work with improper fractions and mixed numbers. So the first problem said 3/4 plus 3/4. So I know if I have fourths and I'm adding fourths, my answer is also going to be that size. The pieces are all going to be fourths. So I'm going to break up these area models for my answer into fourths. And then I have 1, 2, 3, 4, 5, 6 of them. So I can shade in 1, 2, 3. 4/4, that's my first whole. 5, 6. Okay, now you can write your answer in two ways. One way you can write it is as an improper fraction. I now have 6 pieces, and each piece is a fourth big. This is an improper fraction. If I want to write it as a mixed number, well, I'm going to start by writing 1 whole, because that's what this is. 4/4 is the same as 1 whole. And then I have 2/4 left over, so I write it as 1 and 2/4. Sometimes kids get confused about what this means. It literally means 1 plus 2/4. So it's both a whole and 2/4, except mathematicians just don't write the plus sign. So that's what that means, and these are two ways you can write your answer. Okay, now the second problem says 3/4 plus 5/8. This one's a little bit harder because the pieces aren't the same size. So before I do anything, I want to make them the same size. So I see these fourths, and I notice that I can break them up in the same way as the eighths by drawing these lines down here. And basically, I took each fourth and broke it into 2 pieces. So now I have 1, 2, 3, 4, 5, 6, 7, 8 parts, and 6 of them are shaded. So this 3/4 is equivalent to 6/8. And the way to show it without a picture would be to say, okay, 3/4 equals 6/8, because I can multiply the numerator and denominator by 2, and I'll end up getting 6/8. Okay, so now the fractions are the same size pieces, eighths, so I know my answer should also be eighths. And in this first one I have 1, 2, 3, 4, 5, 6, so I'm going to put those here, 1, 2, 3, 4, 5, 6. In the second one I have 1, 2, 3, 4, 5, so I'm going to do 1, 2, notice we're already at a whole, 3, 4, 5. In total, I have 8, 9, 10, 11 eighths. And as a mixed number, that's the same as 1 whole, which is this, plus 3/8. And you just write that as 1 and 3/8 as this mixed number. Okay, the next problem starts off with 1/4. So I'm going to break this whole into 4 equal parts and shade in one of them, plus 7/8. So I'm going to break this whole into 8 equal parts and shade in all but one of them, so 7. And they're not the same size pieces, so I'm going to make them the same size pieces by doing an equivalent fraction. 1/4 is the same as 2/8. And I can show that again by multiplying the numerator and denominator by 2 to get 2/8. So now this is 2/8. And so now since both fractions have the same denominator, I'm adding the same size pieces. So I know my answer is also going to be in eighths. And now I'm going to shade in what I have. So the 1/4 was really 2/8, so 1, 2. Plus 7/8, so 1, 2, 3, 4, 5, 6, 7. And in total, that will give me 9/8. 2 plus 7 is 9. But that's the same as 1 whole, which is this, and 1 more eighth. So 1 plus 1/8 is the same as 1 and 1/8. All right, here's the last two. These I wanted you to try without a picture. So this first problem is really easy because I'm adding the same size pieces already, eighths. 3 of them plus 4 of them is going to equal 7 of them, and they are eighths. This would not quite be a whole, and we could draw a picture of it, but you don't need to. This next problem, we have fourths plus eighths, so they're not the same size piece. So the first thing I want to do is make them the same size. And I can do that by taking fourths and breaking them into eighths. I notice that that's a scale factor of 2. So 3/4 becomes 6/8. These are equivalent fractions. So I'm going to rewrite this one as 6/8. And now it's easy. I have 6 and 7 would give me 13, and the pieces are the same size. They're all eighths. Hopefully, you know how you can take this, the 13/8, and turn it into a mixed number. So I can tell this is going to be more than a whole, because 8/8 would be a whole. So this is the same as 8/8, and then to get 13, there's 5 more. Right? Do you see what I did? I saw that 13 already has an 8 in it, and then I need 5 more to give us 13. So I'm going to rewrite 8/8 as a whole, and then 5/8 is the part. So 13/8 is equivalent to the mixed number 1 and 5/8. On to the 6th grade review ratio problems. The Roadrunner runs 30 miles in 10 minutes. How far will the Roadrunner run in 1 minute? So this is a ratio problem, and I can tell by the 1 minute that this involves the unit rate, because the unit rate is always something per 1. So we're looking for how fast per 1 minute. And what we know is 30 miles in 10 minutes. There's a couple ways you can do this. I'm going to show it with a ratio table. So I set up my table. Miles are the units on top. Minutes are the units on the bottom. And the first ratio they give us is 30 miles in 10 minutes. And I want to find 1 minute. So I'm looking for a way to get from 10 to 1, and I know that I can use division. I can do 10 divided by 10, and that's just going to equal 1. And 30 divided by 10 is going to give me 3, because 10 goes into 30 3 times. And that's my answer. That's the unit rate. The Roadrunner is going to go 3 miles, and I'll say per minute. Now maybe you did this an easier way. You didn't even set up the table. Maybe you just know that division helps with unit rate, and you just did 30 divided by 10. You could also make a double number line starting from 1 minute and 3 miles and go all the way until you get to 30 miles in 10 minutes. The last problem on the homework said, how far will the Roadrunner run in an hour? So let's start with what we know. The first thing we know is that the Roadrunner goes 30 miles in 10 minutes. I wrote this as a ratio, 30 miles for every 10 minutes, or 30 miles to 10 minutes. You could say it either of those ways. And then in part A, we found the unit rate, which was 3 miles for every 1 minute. And the problem asks, how far will the Roadrunner run in an hour? And that hour has me a little worried because so far all we know is minutes. So maybe you figured out that you could just change an hour to how many minutes that is, which is 60 minutes. And now the problem is pretty basic. We need to scale one of these ratios up to 1 hour. I'm going to show this with a double number line. You could have used a different strategy. So I have miles and minutes. I start at 0 for both. And I'm just going to use the ratio they gave us in the problem, 30 miles to 10 minutes. And I'm going to scale that up until I get to 60. Be careful, I did get to a 60, but that's 60 miles. I'm trying to get to 60 minutes, and so far I'm not there yet. Now I'm there. I scaled up by this first ratio until I got to 60 minutes, which is the same as an hour, and the Roadrunner is going so fast, would go 180 miles. I could say per hour. Alright, and then to prove you were here, let's write this secret word. The secret word for today is bodega, where I get my lunch every day. Thank you guys for checking in with this and staying on top of your work. I will see you in class.